is
This
trying to address.
conference will now be recorded.
Uh, I'll repeat that. The problem that this ESUB lab project is trying to address, which is the same problem that the concept map suit is trying to address, is we wanted to think about the technology stack that is required if you were to give a, say, a one-page human readable text describing a climate adaptation challenge, right, to a machine, right? So feed the machine a one-page readable text that describes something like, we use the case of climate resilience in the Chesapeake Bay. Again, this is something we're going to return to in the climate soup, in the concept map soup, I mean. So you will describe the problem that you are trying to solve in the Chesapeake Bay with respect to climate resilience, which is in the under scenarios of climate change, you are anticipated to the Chesapeake Bay area is anticipated to experience things like increasing precipitation, flashy precipitation, increased ambient temperatures, and that leads to a whole suite of problems like runoff, right? So when you rain, and if the chicken farms which are found in the proximity of the Chesapeake Bay, if the chicken farms do not properly constrain and manage their chicken poop, the precipitation, the heavy rains may cause runoff from the chicken poop, which gets washed off into the Chesapeake Bay, and it causes downstream problems like damaging the fisheries, because when you have increased nutrients in Chesapeake Bay, that's going to cause eutrophication, which results in increased growth of algae, which actually is detrimental to the health of fisheries, that kind of thing. So imagine that the resilience planning team puts together a one-page problem statement. Now this one-page problem statement gets fed to the machine. The machine extracts the concepts from that one-page statement. By the way, the one-page statement could be, for example, a request for proposals, right? It could be an RFP, it could be an RFI. But the machine extracts the concepts from there, searches against a knowledge graph repository. In this case, we're calling it a genome repository for certain reasons, but we'll come back to this later. And in this case, what we're going to talk about later is your concept map soup. That's kind of like this knowledge graph repository, right? So the machine searches your problem statement against the knowledge graph repository, and the machine comes back to you and says, "Hey, this resilience planning team, I read your problem statement, and this is what I found in terms of potential solutions. And by solutions, we want science-informed, data-driven solutions, meaning that if the machine picks up a number of solutions that matches the problem statement, we want those solutions, right, to show how data, again later in this demonstration, we're going to use some of the one of the NASA data products, the precipitation data products. How does that precipitation data product connect to a model, right? And how can humans use that model to figure out what to do with the adaptation, resilience or adaptation challenge that they have in the Chesapeake Bay? So the machine picks up these end-to-end solutions, what we are calling the data to decisions solutions, the end-to-end, which shows the connectivity between data models, decisions, right? And the machine says, look, here are three, in this graph that I'm showing on the screen, here are three candidate end-to-end data to decision solutions, right? And this is how these three solutions map to each other, and this is how these three solutions map to your problem statement, so that you are able to see and judge for yourself which of these solutions match closest to a Chesapeake Bay situation. Now, one of these solutions could be designed for example, the Puget Sound area up in Washington State, right? And that's fine. You can adapt it, but the visualization gives you an idea of how closely those other solutions may match your needs, right? And then the idea is that the planners can adapt one of these existing solutions and then contribute their solution back to the knowledge repository. And so when as we launch into the next step of this talk, what I'm going to show you next is an example of one of these solutions. As it happens, one of these solutions that I'm going to show next is a hypothetical solution that we have crafted exactly for the problem statement that we have here. So I'm cheating, but Bill, Arif, and I discussed this, and we figured it's easiest for us to show you an example of what we mean, so that you have an idea of maybe if you are interested, you can contribute to this little part of the data to decision solution. You can contribute one small part of the entire so-called genome, because what you see here on the genome, just as humans have a genome that describes our genetic makeup, and from the genome you can create a human or plant or whatever. So the idea for this resilience genome is, again, this is an end-to-end data to decisions genome that tells you everything you need to put together for data to solutions, science-informed, data-driven solution. So you can contribute your part of the knowledge to any part of the genome that you're an expert in. And so, which is why one of the primary motivations for going this route is that the kinds of resilience challenges and large-scale global environmental challenges that we face are very multidisciplinary, although actually that's a bad word. I prefer to use the word transdisciplinary. It's a very transdisciplinary, and there's an academic distinction between a transdisciplinary problem and a multidisciplinary problem, which we don't get into here. But the bottom line is it requires lots of hands, right? It requires, and I'm keeping in mind who's on this call. It requires people with GIS experience who can help with the visualization part of things. It of course relies on the expertise of agronomists, even relies on the expertise of people who do ontologies, which is are the folks who will help with this piece of concept extraction part of the machinery of the so-called of this engine, search engine, right? And so there are many parts for many of us to play. Each of us probably does one bit of this entire genome, and so the concept map, which I'm going to show next, is one way that we can each tell our part of the story, so that somebody else, meaning some resilience planning team or you yourself, can pick up bits and pieces of the genome, assemble it into your favorite story or your favorite solution, and that's your solution to sell to your bosses, or that's the story to sell to your bosses, right? And so that's what I will get to next. But before I go on to that, so like I said, this diagram and everything else is documented in this document. It's a PDF, and don't bother copying down any of this information here. I will show you where this document is linked to from the wiki page. Right. With that, let me show you the demo of the pathway that we have developed, and then we will. So what we'll do next is we will go through the kind of demo pathway, and I call it a demo pathway because just as those of you who have developed IT before, when you show your clients a finished product, when it is very early in the stages, you have just finished like version 1.0 of it, and you can only do certain things with the product. Like if God forbid, if you let your clients click and play around with the product, they will break it, because the product is not designed to handle X many other things. So for now, this demo path that we are going to demonstrate, it works only for the orange colored nodes. I mean, yes, there are a couple of other things in here which work, but the word here is explore at your own risk, right? So what I'll do for the next, like, I don't know, 10 minutes is to quickly go through to drive down the demo path, just to give you a sense of what's going on. and then we will go back. I'm going to change tabs on the browser. We're going to go back to this wiki, and I'm just going to quickly go through some of the other figures and diagrams that you see here. All right, so let's click down demo path. But before I continue, I can take maybe just one question if anybody has a question about what you have heard so far.
This is Beth. I have a question.
Beth, go ahead.
What kinds of things are those solutions? Are they documents, research papers, or
Good question. So the way that it was envisioned and documented in this ESIP Lab project, it is actually a mix of everything from code to maybe data, but probably data, through to documents. And by documents, we envision a collection of documents that may be haphazardly organized. So in this deliverable on the screen I'm showing here, in this multi-page PDF report that was produced from the ESIP Lab project, we give the example actually of a resilience planning project for a coastal city that is worried that it's going to get drowned, under scenarios of sea level rise, when you have stronger storm surges in addition to the higher sea levels already present in the region. And so what we did there was we looked at a solution, right, in that case, where the solutions came in the form of a whole bunch of documents, as in it was a bunch of resilience planning documents that a team, a private company that's contracted, say, by the state of New Jersey, right, to design a resilience plan for the New Jersey area. Now that contracted team, the contracted company like CH2M Hill or some other company, would produce a whole bunch of documents. So that's the scenario that we thought of. Now, naturally, to expect a machine to crawl through that whole bunch of documents and the code that might support those document findings and the data, it is clearly sci-fi, right? I mean, we're talking about a scenario, you're talking about something 10 plus years at least from now to envision having such a capability like what I showed you on the screen. But nevertheless, we were thinking big at that time, and that was what we wrote in this document. Does that sound too scary for you, Beth? I mean, it is scary. It is scary for me, which is why I'm always, putting the brakes on this and saying, wait, this is kind of a vision.
I know something that you guys might want to take a look at, but I'll bring it up later. This is super interesting. So thank you. I just was curious if those were supposed to be, documents that had been, crawled and indexed or something, or if they were something else. So that's, yes, it sounds scary, but also exciting. So I'll leave it at that. Thank you.
Yeah, and so I would encourage whoever else, everybody else on the telecon to jump in and ask questions like this, because this is exactly what we want. We meaning the Air and Climate Cluster want to engender and to foment. We want to say, yeah, hey, if you are excited about this idea and if you have your own expertise and you have your own vision, by all means, run with it and make good with what your ideas are and develop your ideas. I think that's one of the best things about ESIP is we come here, we talk about ideas, and go forth and multiply kind of thing. So I'm glad this has caught your attention there. Great.
Hey, Brian.
Yes.
Hey, Brian. It's Dave Jones from the
Dave.
Disaster Cluster.
Hello, disastrous Dave. No, I'm just kidding.
How are you? I just had two questions. You can decide to answer them now or maybe later as you go through. The first one is, would I look at this as applying this sort of decision pathway, applying it to our disasters cluster? Or would we apply it to specific use cases for a decision maker?
I'm glad you asked that. So No, actually, you could apply it to the decisions class. So imagine instead of the problem statement, it for the scenarios that you're facing with here will be a disaster recovery problem statement. It's like, yeah, you know, not Vermont. Okay, Boston. Boston got hit with our next nor'easter, and it happened to be an especially bad one, and it knocked out a whole bunch of power cables, and it knocked out a whole bunch, and it drowned a whole bunch of electrical transformers, you know, that were not elevated above the flood stage level. Right, this will be in a problem statement. And then the knowledge graph or the concept maps as we're going to show next would actually show that one of the solutions, in fact, many of the solutions use GeoCollaborate, right? And the kinds of data layers that were useful for that scenario that GeoCollaborate pulled in were X, Y, and Z. And those data products that were put into GeoCollaborate had the operational readiness level of, you know, again, 1, 2, and 3. So I think anyway, but again, no, that we none of us have the technology to actually do that search and extract scenario that I just painted out. But the idea is that, yeah, you could, and I would argue, especially in the case of disaster response as opposed to disaster planning. For disaster response, you would find this kind of capability very useful, to have a machine read the human readable text of the description of the problem, and then it goes and figures out, you know, what other people have done in a similar scenario.
Okay, that sounds good. My second question, I think you answered, was how does this differ from a product out there called mind maps? You know, where you're trying to map your stuff, but it sounds like there's more intelligence behind what you guys are working on.
Yeah, so great. I would, Dave, this is an excellent question. I will use your question to segue into the next part. Now, the difference between mind maps and at least the CMAP, the CMAP is the name of the software that we're using for this, is CMAP is used, well, actually the version of CMAP is used by the ontological community. So I think like Beth Hafner, who's on the call here, and many others who use CMAP CMAP. Beth, remind me again, what's the other variant of CMAP that you guys use?
I've been using CMAP. I think, though, there is something that's called mind mapping that's a similar type of tool.
Okay.
I haven't used that one though myself. I use CMAPs usually, but I have to say I use it only for playing around and you know, sketching out my thoughts about about doing something more formal, I guess. So I haven't ever used it in a very systematic way.
Right, and so what we're trying to do here, at least we experimented but not fully executed. And Dave, I'm getting to your question of CMAP versus mind map or some other software, and also Dave, your comment about well, at least I'm interpreting your comment that, you know, what you're about to see here, the way that we've crafted the concept maps, we're trying to achieve a balance between a representation of the concept map that can be read by the machine, we think, and a representation of the concept map that can be read by humans. And I'll give you an example here, right here on the screen that you are showing, that I'm showing. So if you look at the word data services here, what my cursor is hovering over, the data services, I cannot be sure, but I'm sure there is in some ontology there is an entry. Somebody has already defined data services and the relation of this term data services to other things in a typical technology stack. So I think this term data services might have been defined in some other ontology. But if you look at this place where my cursor is hovering over, has components, and there's this funny thing called SAMN. It's not quite working right now, but wait, here we go. If I hover my cursor over SAM-N, this has component. Well, it's not quite working here. Anyway, there you see. Has component, as you can see, it is actually a reference to the suite ontology, the NASA suite ontology. So the NASA suite ontology has actually defined the relationship has component in a way that can be used by a machine for machine inferencing. Well, I mean, I don't know if the folks who are doing the suite ontology really, I mean, they did this in anticipation of some machine reasoner using a graph which is labeled as follows to do some reasoning. The issue with a node like this, like my cursor is hovering over, decision-making use cases built on science, technology, policy components, that's quite hard for a machine to quote unquote understand, because it is unlikely that you will have an entry in an ontology that is exactly like this, decision-making use cases built on science, technology components. It's almost impossible. So part of the answer to your question, Dave, about why we're choosing this particular route, this route, meaning this tool called CMaps, and the way that the concept maps here are phrased and structured is because we're trying to achieve a balance between human readability and also the potential for these concept maps to be parsed by a machine. And so the idea of being parsed by a machine, I know it's a little bit scary. Again, this is going back to your question earlier about, you know, how realistic is this that we're talking about? You know, and I look forward to your comments later. Personally, I'm still nervous about this, but you know, I bet there are a lot of smarter people than me who say, yeah, we can parse this concept map. Anyway, so this is the, let me continue with the presentation here. So this is the kind of your entry point, your entry portal into the concept map repository, or just concept map soup or C soup. I'm just going to call it C soup for ease of reference, right? But the C soup is thematically organized by, excuse me, the decision-making use cases, right? The one that we're going to look at is and on the demo path, it's the Chesapeake Bay resilience planning use case. There's another one which is a little bit completed, but not quite on the demo path. So click on this at your own risk. But if you're interested in American Indian tribal resilience and how the American Indian tribes have claimed that the U.S. government has broken the promises made in treaties dating back, I think, to 1850, right? You should go down this path, the Yakima River Basin Resilience Plan, right? So these are the use cases that we're going to, this Chesapeake Bay use case is the one that we're going to dive into. But we also, now from these use cases, there are components in these use cases that will map to this other stuff on the map, meaning that as we go down the use case, you will see, for example, that for the Chesapeake Bay use case, we will end up at a component inside data services, and that is Bill Tang's contribution when we talk about data rods. Data rods is a kind of data service, so we will end up, you know, in bits and pieces of here. So in general, right? In general, we might have some technology implementation, some technology products like data rods, and for those of you who do this, like OpenDAP, right, might be another technology that we explore here. Informatic methods are interesting in that for those of us who are trying to catch up and learn, you know, some of the landscape of data science and machine learning methods, this is where we will end up, right? Semantic technologies, and for those of you who are interested in policy instruments for science, technology, and the environment, you will go here. But as we go down the demo path, you will see that there are elements here in the demo path that goes back to policy instruments. So let's take a look now. If you click here, if you click on the demo path, it will bring up the Chesapeake Bay resilience planning effort, right? And so what I will not go through each of the little boxes here. But if you look at this big challenge that is facing the Chesapeake Bay watershed, we have threats to our coastal gray infrastructure along the Chesapeake Bay. We have threats because of extreme precipitation and particularly sea level rise to the water treatment facilities, right? We have threats to the oyster habitats, and we also have threats to our poultry agriculture, right? And so this is where, again, the poultry agriculture part is on the demo path. And so we will dive down this path, right, to take a look at what's underneath the issues regarding poultry agriculture. Now, for the poultry agriculture issues, right, we are looking at threats to the poultry feed facilities, the facilities that actually provide the food to the chicken farms and the actual farms that raise the poultry. We're also looking at facing the threats of changing disease patterns, especially as you cluster your poultry in, think of the avian flu, right? And things like that. Increased threat of flooding, warmer summers, changing precipitation patterns, and also things like increased nutrient loads as a result of changing precipitation patterns. But if you think about increased nutrient loads, then you need to be aware that the government the government is empowered to sue, well, to take you to court if pollutants in the water exceed a certain level, and those that legal power that the government has is set in the Clean Water Act. And so here, for example, there are concept maps that go to describe a little bit about what the Clean Water Act is. And then this Clean Water Act is actually a larger piece of the puzzle, right? The Clean Water Act is only it's a statute, it's a piece of law. But in addition to the piece of law, right, you have things like regulations, and you might have things like executive orders. So how does all this fit into the big picture? And so this is where you would go to click to find out more. But those things are not on the demo path, right? We will ignore those things. We will go down to the demo path to this tool called the EPA Basins Tool. Now, the EPA Basins Tool is a tool for characterizing the risk from climate impacts, because this step here is one of the steps, which is to assess vulnerability and risks. And this step is actually specified in something called the US Climate Resilience Toolkit, right? So we are kind of following the cookbook example of the US Climate Resilience Toolkit, which was developed under President Obama's Climate Action Plan. Now, the EPA Basins Tool, if you click on the link there, it gives the Climate Basins Tool. This is the overview. What this concept map tells you is that the EPA Basins Tool is capable of running a whole bunch of integrated models that are integrated with the tool. The two components also includes a facility for the user to retrieve environmental data, and one of the pieces of environmental data is the NLDAS precipitation data product from NASA, and you can, from within the tool, you can get access to the NLDAS precip data using data rods, which is a technology developed by Bill Tang and his gang at NASA Goddard. And so this is the concept map that Bill has put together, right? And there are again embedded concepts here that you can use to drill down. Like Bill has a concept map, which I will not go into right now yet, on explaining what is data cubes, right? So that there is this other concept here. So I will very quickly switch back to the other screen, which is the wiki page, and I will scroll down the wiki page. But what you just saw that I presented is this figure on the wiki page. Now, this figure on the wiki page is clickable. So this figure gives you the high level summary of what we just did, right? We went through the demo path. We started with the use case of Chesapeake resilience planning. We saw within the larger context of Chesapeake Bay resilience planning, we focused on poultry agriculture. And in order to assess the threats and analyze the threats to poultry agriculture, we went down the path of the EPA Basins Tool. And from the Basins Tool, you actually use data rods, and then you end up at one of the NASA data products. So this is like an example of the data, which is here, the data to decisions pathway, right? This is the genome that we've been talking about, right? This pathway is a genome. There is an alternate pathway. You can call it a subgenome. You can call it, part of the genome is one whole messy genome, whatever. But the idea is that this whole thing is the genome. So where you fit in, as you can see, there are lots of places in the concept map which we have not developed. And you all each have your own individual expertise areas, right? That can be used, and we could use your expertise to plug in the gaps that we have, the many places along this pathway. And so going back again to the first part of the presentation, I'm going to switch. Remember the screen? And this is the genome that I just showed on the other screen, right? So we want to see whether your concept maps can be plugged into this overall genome. Again, let me just emphasize again, I need to emphasize this very strongly. There are two purposes, at least right now, to a concept map like this, right? The first purpose is as an education, well, kind of an educational and communication tool, right? It's now for most people, at least, this kind of visual representation is a little bit easier, although that's not true. I have come across folks who tell me that this kind of concept representation is a little bit messy, and so we each all have our own preferred learning methods. But this method is one method. This visual method is one method that has been used to capture stakeholder needs. Like if you were to put together a whole bunch of stakeholders within the Chesapeake Bay area, people from the government, people from businesses, scientists, planners, and to lock them into the room when we don't have a COVID problem going on. You lock them into a room and you say, guys, you all have a different view of the challenge before us. You all have your own different needs. The business folks say they need business continuity. I want to get my businesses up within 5 days of a flood. So again, Dave Jones, going back to disaster response, that could be one of the needs in terms of business continuity, in terms of getting parts of the city or certain critical services back up to speed, like hospitals, for example. Anyway, you get a whole bunch of different stakeholders in a room, and one of the ways that we have used successfully is to capture all of their needs. Some of them are not necessarily aligned, but capture all their needs in a concept diagram like this. So you can feed this. One of the ideas that we have been thinking of is you feed this concept map to the machine search algorithm that will pull out potential solutions, or you describe this concept map in terms of a human readable text. Again, going back to the earlier diagram, it's a one-page description of the problem. So multiple ways of doing it. But let me say before I end this presentation and turn it open for questions again, is the two purposes, right? One is these concept maps have to, at a certain level, they have to be human. Well, they have to be easy to read by humans. But we also want to be careful that as we are developing these concept maps, it is useful to keep another potential use in mind. And the potential use is these concept maps, you could expose them to a machine. And for that reason, the machine can only, quote unquote, understand certain things. And so this is where the semantic annotations, if you can see here, when I hover my cursor over this thing called has part is actually an entry in an ontology with an ID BFO:00000051. So the machine, you can create a machine reasoner that understands what do you mean by S part. So again, this is a struggle, right? It is a fine balancing act that if you are hoping to contribute to the concept map, this is something that we'll have to keep in the forefront of our mind. And what you can take away, the most important thing for me, take away from this talk, I guess, is I wouldn't read all of the 4 points here on why we're doing this, but let me just highlight this first point is the ability to develop your own story. And often the time comes when your program manager, your boss comes and taps you on the shoulder and say, hey, this piece of technology that you're developing, could you tell me what are the future implications of this technology? So if we had a whole bunch of concepts available for you to use, you could put together your own story, just like here, just like what you see in front of the story on the screen. This is a story assembled from very detailed concept maps. But you would give this story back to your boss and say, hey, in this case, pretend that Bill Ting's boss is coming after him, and Bill Ting's boss says, hey, what's good with this? What's the use of this data rods? And so Bill Ting will say, hey, this is data rods that we've developed here, and look at all the upstream potential users that we have documented. So that's the kind of story that we think you can tell. And this is a wonderful way of learning about things that you may not immediately know about because it is not your area of responsibility. Like if for some of us, like I used to be stuck in the world of policy. It sometimes it is necessary for me to see the actions that are constrained by policy. How do they constrain the types of things that happen downstream of national policy? So this is useful for me. And so with that, let me stop and take questions.
Okay, hey, Brian.
Huh?
All right, this is Dave again. I had to find the mute button. So yeah, it's really interesting. I'm just wondering how we might be able to use this approach, and I'm not calling it in my mind a concept map schema, but more of a trusted data traceability, maybe. So we can use it as an ORL mapping tool. So, there are a couple things I'm thinking about. Perhaps one is to use this to identify a use case, but I want to be able to identify the data sources, the trusted data sources that's going to help those decisions.
Right.
And then it would help us visually communicate how, why this data is trusted. Where's its source? We can put it into the survey 1, 2, 3 questions that spits out an ORL, which is what that survey 1, 2, 3 thing does for ORLs. But really, I'm wondering how we can use it to tell the story of, look, we're answering this use case. We've identified your key decision-making points.
Right.
And here is the data, the trusted data that allows you to do that. So it's kind of providing traceability for not only are we addressing decision makers' requirements, but we're addressing the map to the data, which might be some sort of REST service.
Right.
Is that the way I should be thinking?
Yeah, exactly. I mean, so the operational readiness. I mean, the operational readiness level that you associate with data sets, it can be documented on this pathway somewhere. The data sets, for example, in this case where my cursor screen is hovering over, right? This is just one data set, the LDES precip product that we are highlighting, but naturally, for a specific emergency or disaster response situation, like when you participated in the wargaming exercises, I bet, and about that and actual responses to actual emergencies, I bet they have gathered quite a bit of knowledge about which of the data products are useful and what is the ORL required of those data products for them to be useful, right? And so that kind of traceability is easily captured if you express it as a concept map. But having a machine go through and parse the concept map in order to answer questions, that'll be a little bit tricky. I mean, not impossible, but tricky. But basically, that's what we are proposing here. Also, we are proposing that ultimately, a number of years down the road, and maybe Bev has other ideas that will reduce the number of years. The number of years down the road, you'll have a reasoner who knows how to handle these concept maps, which are kind of human readable, but kind of we kind of kind of machine readable also. Am I answering your question, or Dave, or you were asking something else?
I mean, I'm just thinking that if you go down a road that you want to, that's going to help you identify use cases and ways to get to data, that if you're approaching it this way, where ultimately it might be machine readable, then you can start to put some intelligence into it. So people can say, look, I am a chicken farmer. Here's what I want. And it can work backwards to sources of data. Then they can take those sources of data and put them right into their decision-making pool.
Precisely.
Right. So it's, I mean, it would be interesting to see the sort of like the planned evolution for something like this. So, it would help me choose between spending a lot of time using a mind map that might not have intelligence behind it. I don't know, maybe it does. Or this kind of approach where the intent is to put intelligence behind it. Where, in the future, I can say, look, I did all this work for a few years. Now we can plug it into a machine. That's the kind of thinking I'm going down.
What I show you on the screen is a different representation of the resilience genome, but going back to what you said about specifying the data and maybe the situation and having the machine figure out everything else in between, and situations which closely match your parameters. So what I'm showing here on the screen is you read this diagram from top to bottom, steps 1 to step 5, but this part of the diagram is where in the scenario that you painted, the user, the emergency response commander would specify as many parameters as he or she knows is relevant to the situation that he or she is facing, right? The emergency response commander could say, I'm dealing with a problem of a hospital being flooded, and I need to get my hospital up within 5 days. Unfortunately, there's a bunch of zombies running around, and I need to, my crew needs to avoid being eaten by the zombies or whatever. Right? So what the person has specified are, if you look at where my cursor is hovering over, this is the entire genome, the whole data to decisions and of things, the whole data to decisions traceability, right? The decision maker should be able to specify as much information as the decision maker has, whether the information is about data or whether the criteria is about zombies running around, which is a threat of data. So this is another way of looking at it. But yeah, we don't quite. I don't know. I would invite other inputs, but it's kind of hard to do it right now. I mean, in the good old days of AI, we used to call this kind of thing case-based reasoning, CBR. But I think it's kind of fallen out of fashion a little bit. But I think it's time to bring it back.
Well, one quick thing. I know there's only a minute left, so apologize for monopolizing here a little bit. But if we apply it to a use case where we've had Karen Andres from the National Weather Service has participated in your cluster, she's participated in the disaster lifecycle cluster, and she's looking for data sources that will give her soil conditions that change the runoff and hydrophobicity of the soil, which ultimately changes their watch and warning criteria for flooding, debris flows, and mud flows. And so I'm wondering how maybe you can give a stab at using this and focusing in on her use case that would keep her engaged with the clusters. Number one,
yeah, that's a great
number
idea.
two, really help address a real problem that she has. I mean, because they have these things called bear teams from the Department of Interior or Forest Service or wherever they come from, which comes in and they do soil analysis after fires are over. But when they do the analysis, that information isn't available for like 30 days. So there's a 30-day window of when it can start raining and when they could have major mud flows and debris flows and stuff like that. And I'm just wondering if we can show her that we're working on her problem to identify trusted data sources,
right?
And what's available, what's not available yet, what needs to be calculated based on derivations from other imagery and data, but to show her that way she'll say, hey, all right, they're working on my problem, and she's from the National Weather Service, right? So we could get high visibility if something's successful.
I think that's an excellent idea, and I'll invite Bill to jump in here. And so, Bill, I think what Dave is suggesting here is another almost like this is a demo pathway that is responsive to the needs of an emergency response commander. And I think that's a great idea.
And just real quickly, Karen works with the National Weather Service. She's the Western Region Hydrology Program Manager. And so she's not a disaster responder, but she's a official voice for watches, warnings, and advisories from the Weather Service.
Okay.
I think this is Megan Carter here. I'm sorry to jump in. I know probably a lot of people have to run away for the next meeting, but quick question, Brian, like what is the best place to follow up with you about this? Is this a great way to use the new Slack channel to continue to have these conversations?
That's a great idea. Let's follow this up on Slack, man. If you have other questions.
You guys are welcome to continue, but I know I personally have to go.
Okay.
Yeah, I definitely think Slack would be a good meaning for us to continue this. And Dave, so you're referring to Catherine Rowden? Was that?
Yes.
Okay. Yeah. So I've been in touch with her regarding these telecons, and in fact, for the summer, right? We originally were thinking a second session, following up on the wildfires and soil session we had in January. But we may not have enough resources to do both. And so, in fact, I was thinking the geosemantics symposium that's usually precedes the ESA meeting. I saw somewhere that they were talking about asking people to contribute use cases. So I was thinking, in lieu of a separate session, perhaps we can explore somehow participating in that event with some kind of use case around wildfires and soils response. And what you and Brian were just talking about in terms of creating another use case concept map, around that topic, perhaps could be rolled into all that. So we could explore this further using Slack.
That's cool. And I'm sorry, I have to jump off too, but I'll I guess when an email gets sent out about the Slack channel, I didn't see that topic for the disaster lifecycle cluster, but I'm wondering if that might be a good idea for us too. But anyway, I'm interested in being a part of it.
Great. So I have 4:04, 4 minutes after the hour. So well, first of all, thank you, Brian, for taking us the tour through the sea soup. Any last Any comments or anything from anyone before we sign off?
Well, this is Beth. I just want to say this is really, really interesting. And I can't wait to talk more with you guys about it. So
Great.
I won't start down any paths right now because I think it will take us well over time. So, but I do think this is really interesting, and I just wanted to let you know that. So
Great. Thank you.
This is Brian. I think Bill and myself, and Arif would try to set up a separate call with you sometime very soon, like next few days.
cool.
Okay, we will follow up with notes and whatever links that might be useful. Okay, other than that, thank you very much. We will talk to everybody next month. Thank you.
Thanks, guys. Bye-bye.
Bye now.
Bye.